here is just an example. We're talking today about another way, our last way to solve a quadratic equation. So here's our situation. Your friend's Anne has a brick walkway. She wants to decrease the length by the same amount that she increases the width. And she wants the area to be 310 feet. So we have to figure out if this is possible. Is it even possible that she can take a certain amount away from the length, add that same amount into the width, and end up with an area of 310? Now, if I decrease this length by x, and I increase the width by x, this unknown value, how would I rewrite my dimensions? What would my new length be? If it's 30 now, what would it be if I wanted to take away x? 30 minus x. Good. Bye.
I'm just going to find out. I need to ask you. Do you have
No, I don't give this an assessment. No, I don't. I can check with some of the general ed tomorrow and see if they have them.
I really don't.
Seventh grade, I don't. You would have to reach out to seventh grade teachers since they weren't given to me. They were given to ninth grade teachers. But I can find out for eighth grade.
Thank you so much.
So our new length is going to be 30 minus that unknown value. What will our new width be? 5 plus x. Good. And when I do that calculation, I multiply the length times the width. What do I want the area to be? I want it to be 310. So now, how would we solve this? Let's just go through. If I distributed it out, I have 150 plus 30x minus 5x minus x squared equals 310. Okay, so I simplified it out. I haven't yet put it into standard form, but let's just pause for a moment. How could I solve it? What are my options for solving a quadratic? Okay, I could try to factor it. Good. What else can I do? Let's say it doesn't factor. Does this one factor? No, this is not going to factor. What else could I try? I could try to complete the square. Good. Depending on if there's a b-value or not, could find the square root. Okay. Is there a value for x that would satisfy this equation?
No.
No, and that's possible. So, I know. I was going to let it hang for longer, but we're running out of time.
She was like,
Well, no one can see me shaking my head. So if it's possible, especially if this is a real situation, is there a value that we can take away from the length and add to the width and end up with an area of 310? The answer there is no. If you went through and completed the square, you wouldn't have found an answer, right? At least nothing that would have been possible. You would have had no solution. So quadratics can have two solutions, one solution or no solutions. We did talk about this earlier. What does a solution look like for a quadratic? Like, where do we see it in the graph?
when that.
When our quadratic crosses the x-axis. So if our quadratic has no solution, what does our graph look like? Still curved. Yeah, it's above and goes up or below and goes down. It never crosses. If we have two solutions, it would crisscross, right? You would see it two times. If there's one solution, it would touch the line, the x-axis, just once.
Wait.
You wrote this down like the first day we did quadratics.
Oh, I probably did.
It's okay. The topic that we're talking about today is twofold. We're learning today what the quadratic equation. The quadratic equation is a way for you to solve quadratics. It's also a way to determine with a very, very small calculation if there are going to be one solution, two solutions, or no solutions to your quadratic. And we're going to do that portion on Friday. Today we're just going to use the formula and check how we can calculate and solve quadratic. The wonderful thing about the quadratic formula, it is given to you on the reference sheet of the parking exam. You don't have to memorize it, it is given. So if you are asked at any point in time to solve a quadratic, and you have a brain fart, and you forget how to factor, you forget how to complete the square, you could use the quadratic formula which is provided and you will get the same answer. And the quadratic formula is awesome because whether it's factorable or not, quadratic formula works. If there's a coefficient bigger than 1 or smaller than 1, quadratic formula will work. If completing the square is too time consuming, quadratic formula will work. Yeah.
is that crossing twice because
This one's crossing twice. It's crossing here and here. This one's crossing just once because it's just touching it. And then this one doesn't cross at all.
okay.
So if we just graphed the situation we had gone through with the value away from the patio and added to the patio, it would have looked like one of these. It would never have crossed. There are no real number solutions. So now let's talk about the quadratic formula.
It sounds like a rubber
You can
duck.
find the solution of any quadratic using this quadratic formula. So here it is. I want you to write down the formula. You're going to see it a million times. On the next slide, we're going to go through where you get the numbers from. That's good. So the first part, if ax squared, this is our standard form of a quadratic, ax squared plus bx plus c. And they always specify that a cannot equal 0. The reason a cannot equal 0, if a were 0, that is no longer quadratic because I have 0x squared. It's just a linear equation.
Why does it have to be 4?
That I'm going to show you. I'm going to show you how the quadratic formula is derived. You will not have to do it, but I'll show you where it comes from. To be honest with you, if you had to, you could derive the formula because when we derive the quadratic formula, all we're doing is rewriting our quadratic equation that's in standard form. We're just getting x by itself. That's this. We went from this to that by just moving stuff around. It is actually a literal equation. I'll show you the derivation on the next few slides, but the most important thing is that you can utilize the formula. In high school, there may come a point in time where you're expected to derive it, but even that, there's a strong chance you won't have to. So here's our formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You are given the formula so you don't have to memorize it. Way back when I was in school, we had to memorize it. So I still have it memorized. Because you can use this. You can use this anytime. This is when all else fails, you can use the quadratic formula. And you're given it, which is nice. So if you ever had that that moment where you're like, oh my gosh, I'm going to go on the park, I'm going to forget everything, I'm not going to be able to solve a quadratic equation. You can. You can open the formula's reference sheet at any time. Doesn't matter if it's calculator or non-calculator section. And you'd be able to use this formula. Now I'm going to show you where the values come from. So here, we already know the a value, the b value, and the c value of standard form. The a is the coefficient of the x squared, the b is the coefficient of the x, and then the c value is the constant. All you're doing is plugging in the values where they go on the formula. Now, and I did it in color so you could see it. Anywhere you see an a, you would plug in here a 2. So I will actually rewrite it here. I'll do it this way. So anywhere I see an A, I'm going to plug in a 2. What's very important to remember, you're only substituting in a number. Like, you're not putting in 2x. It's just a 2. Anywhere you see a B, you're going to put that B value. It's a 3. You have to be careful here because the first term is negative B. So I'm going to put that 3 in a parenthesis. If it's a negative, it would have been like negative, inside parentheses, negative 3, but it's not fun. And then here I have another 3. And then anywhere I see a C, I'm going to plug in a negative 5. And that's it. Now, we're going to calculate that so you can see. But that's just taking a formula, and it doesn't matter how basic or how complex the formula is. The A, B, and C value can be identified, especially when our equation is in standard form, and we can substitute in the values where they go. If you notice, the only variable left in my equation is the x. The entire other side is numbers now, because I was able to replace the A value, the B value, and the C value with the numbers that match them. I'm going to scroll. So now if I were to calculate this, think back to your order of operations, where would you begin?
Parentheses.
Okay, you can, okay, cool. So where? What do you want to do?
-3.
Okay, so this is a -3, good. What else?
Well, 4 times 2.
Okay, so you can do -4 times 2, which is -8, and then you can do -8 times -5, which is +40. Good, what else can I do? The denominator is a 4, because I did 2 times 2, and then what? And then, yeah, the exponent, 3 squared, which is 9. Okay. I'm gonna scroll down. Now what?
Multiply.
Yeah, inside my radical is actually the number 49.
Where?
40 plus 9.
Oh.
So now I have that.
All of these.
Now what would you do? Okay, I know the square root of 49. You guys better be writing this down. Right? Not you. Square root of 49 is what? 7 or -7. That's why they put the plus or minus there for you. Right? So now what I'm going to do, I'm going to actually do it this way. -3 plus 7 over 4 or -3 minus 7 over 4.
Wait. Wait. So we put both of
I'm
those.
gonna go. Here we are. I plugged in the numbers, calculated through. Just I removed that parentheses, simplified here to get this. Okay. Then at this level, I simplified inside my radical to get a 49. So now my problem is -3 plus or minus the square root of 49 over 4. That plus minus is there because that would be when you square root the positive or negative. They actually do it in advance for you. So now that means my answer, x is -3 plus the square root of 49 or -3 minus the square root of 49. That's where that plus minus comes from. That's why I have 2 answers.
Do we write both of those?
Yep.
Can you go back up?
Which one? To the beginning? Let me finish it, then I'm going to go back to the beginning. So the last thing I can simplify now. -3 plus 7 is 4. So this is 4 over 4. My answer is 1. X is 1. Here, -3 minus 7 is -10. -10 over 4 is -2.5.
Can't believe their answers are so
So our answers here are x is 1 and x is -2.5. I'm going to scroll, even if you're still writing, I'm going to go up to the top and then we're going to go back down together. I felt really good with period 3-4. I was like, yeah, they got it. And then I graded the DOLs and oh my god, it was bad. So we're going to go over the number 9. I'm looking at like, where'd you make these numbers up? You're not making anything up. You're just plugging in the numbers that you're given. And a big problem that they did, a lot of them, like when they were plugging in like this B value, they put like 3x. But you don't want to bring in a variable. You're only putting in the numbers.
How come?
So here's where we got the numbers from. So all the way back. Our original equation was 2x squared, so our A value is just the 2. Our B was a +3, and our C was -5. I took that A, B, and C value and just plugged them in to this formula. Anywhere I saw a B, I put in a 3, here and here. Anywhere I saw an A, I put in a 2, here and here. And anywhere I saw a C, I put in the -5, which was here. At this level, you can just simplify. You have all numbers now, you can simplify and calculate.
And we use the order of operations.
Yeah, you would use, and you could go, really, if you wanted to do, like, if you wanted to simplify the denominator first and, like, then go inside the radical, you could. But think about what needs to be done. You're going to have to square the number 3. You'll have to multiply these 3 terms. A big thing that the earlier class forgot was the signs. Like, most of them, the mistakes they made was because they forgot that, like, if you multiply the negative and a negative, it ended up being positive. So they were messing up. Those are the little things. And this is what happens. You start to work with complex stuff, and you do this, and you make the little mistake of like, oh, I forgot. I get negative and negative is multiplied by negative is positive. That's where some of the problems come in. So when we simplify it out, a negative 3 is here. 3 squared is 9. Negative 4 times positive 2 times negative 5 is positive 40. When I simplify everything in the radical, oh, and my denominator is 4. When I simplify everything in the radical, this is 49, which comes here, and I can simplify it here. At this point, when I square root 49, the square root of 49 is positive 7 or negative 7. Right, it can be either one. That's kind of where we get those two solutions to a quadratic. When you were completing the square, you would do like the positive or the negative. Same idea. The nice thing is the formula puts that positive or negative in there for you. So that's your reminder. At this point, once I find the square root, negative 3 plus 7 divided by 4 would be a solution. And over here, negative 3 minus 7 divided by 4 would be a solution. So, and then I can just simplify them both, so my answers there would be 1 and negative 2.5. Yeah. How far? You're going to try one. We'll look through it. You're going to try one using the formula.
And this works every time.
Every time.
In any, I think I find this.
Any quadratic.
Why couldn't you show us this before?
Uh,
This is easy. Like, I was thinking of that too, but I didn't want to add. This hardest comes first.
Honestly, I usually do this last because if we didn't have the time to get to it, I could at least just show you the formula knowing you'd be able to plug in numbers.
After a storm, there's a rainbow.
Thanks, Sarah.
Why is there like 6 methods to do one?
Well, because you can't always factor, right? You may not want to complete the square. There might be times where you wouldn't want. Here's the thing: if something was easily factorable, make no mistake, this is time consuming. And the more steps you have to something, the more room for error. So if you had something like x squared plus 6x plus 5. Like, I could factor that. So, right, factors of 5 that add up to 6, positive 5, positive 1. That, you can do that with the quadratic formula. Your a is 1, your b is 6, your c is 5. You can do that. That would take you so much
Yeah, but
longer
why
than just
is it-
factoring it right now. Right, so we start with your basics. If you can factor real quick, you can do that. If you looked at this and you're like, oh my gosh, I totally forget how to factor, sure, you can plug in the b value of 6, the c value of 5, but why would you at that point if you do something faster? So now we're gonna move forward a little. Okay. So I'm gonna show you where it comes from. Just sit back and relax. My dad is shy.
There is no relaxing level.
Oh my gosh, you make it seem so bad.
It is.
Are you recording this?
Yeah.
Exposed.
Okay, so I'm just going to show you where it comes from. You do not have to write anything down. Just entertain me and watch the show. Most of the work is done here. I'm just going to explain. So really, when we use the quadratic formula, it's just a literal equation. It is actually the standard form of a quadratic rewritten to get x alone. And here's how we would do that if we had to. First, if I want to get x by itself, I can divide everything. I can divide out the a. I don't want there to be a coefficient, so I'm going to divide everything by a. Okay? When I'm at this level, my problem now is I can see 2 x's, and I only want there to be 1. So at this point, I'm going to complete the square. Right? You can complete the square so that at the end you solve just for x. By completing the square, what would I have to get rid of here? I would have to get rid of the c value, which right now is c over a. So I'm going to subtract c over a from both. Don't worry, you don't have to. So I subtracted c over a. At this point, I'm going to complete the square. I'm going to use that b divided by 2 squared, and whatever I come up with, I'm going to add to both sides. There it is in red. Okay. At this level here, I'm going to find my common denominator, so I can add them together, which is like down at this level. But on the left side, I can take that trinomial and rewrite it as a binomial, that binomial squared. So I'm here. I'm actually I'm down here. I write it as a binomial square. On the right side, this portion is just getting a common denominator. Remember, like common denominator, you could, if you needed to make this a 4a squared, you multiply by 4a. Right, you see that. So now we're here. After we found a common denominator on the right side and combined them, and on the left side, we just have that binomial squared. Now, what would I do to get x alone? I could square root both sides, and then what am I going to subtract?
The b over 2.
Yeah, at that point, I'm going to square root both sides, getting this plus or minus that whole thing. And then when I subtract the b over 2a, notice here, this is a common denominator, so I can just rewrite it all over 2a. And that's where it came from. Crazy, right? I'm exhausted, I need to do it, I just have a picture. But yeah, if at any point in time in your mathematical career you would have to derive that and kind of show how we went from one to the other, you could. I mean, it's obviously very complex, but you're just doing all of the steps to get x by itself. But that's why it works, because ultimately you're just using the a, the b, and the c values of the quadratic. You're plugging those in to get the x. Okay. Okay, if I wanted to use the quadratic formula for this problem, why do you need to put it in standard form first?
Yeah. No C values.
Is there no c value?
Or is it just from percentage?
Well, there is one, but like, do you know which is which right now?
No.
No, it's actually going to be a little bit easier for you if you put them in standard form first, because you know when it's in standard form which represents A, which represents B, and which represents C. How would I put that in standard form?
Subtract the 2x.
Yep, I can subtract the 2x, and how would I write the left side of my quadratic?
Yeah, x squared. This 2x minus 8 equals 0.
So what is my A value, my B value, and my C value?
A is 1,
Okay, A is 1,
B is 2.
B is negative
Oh, negative 2.
Negative
C is negative 8.
Okay, so using those values, use the quadratic formula and solve. Try it real quick. Plug in what you know, calculate it out.
Pardon the interruption. May I please have Sarai Flores with her things to the office?
Yes.
Hello?
Yeah, she's on her way.
Thank you.
Who, me?
Yeah.
What is
With
that?
her stuff or just for a minute?
Oh, no, just for a minute.
Just for a minute, she needs to talk to you.
Oh, my child. Oh, yeah, okay.